So, hello, my dear friends. I hope everybody is fine. It's a long time that I've uploaded a video. In today's video, we'll just discuss the chapter that is sound, class 8 chapter sound. So, this is the part 1 of the video. So, let's start. So, today's learning objectives are definition of sound, example of sound by rubber band, compression and rarefaction, transverse and longitudinal waves, types of waves and their explanation, terms related to sound wave, displacement time graph, displacement distance graph, sound intensity and characteristics of sound. So without any further ado, let's go. So here is the picture of compression and rarefaction. So here, friends, you can easily see the wave which are farther away from one another than they normally are said as rarefaction, and the the lines which are close to each other as the normally are, because here in this wave the state is beyond the normal state. So here two of the beyond farther and beyond close, okay, very close and very far, that is called is compression and rarefaction. So without any further ado, let's go to the next slide. Wait, let me show you one one you can say one one you can say diagram. So take the color as blue. So here I am drawing, yes, please ignore, like this, like this, like this, like this. Wait a minute. Let me show, like this, like this, like this, like this. This is C, sorry, this is compression. And what is rarefaction? Like this, like this, like this, like this. The lines are beyond the farther state. This is called as rarefaction. Okay, hope you can understood from this diagram. Let's move to the next slide. Okay, so before going to the definition of sound, let's get an example to know what is this sound, what is this. So what you have to do is take a small rubber band and cut the rubber band into to get a string. Cut the rubber band means from the lower end you will cut it to get a string, and what you will do, you will take the string up and keeping its one end in your mouth under the teeth, you will press it and you will not let it go one hand, you will press it tightly, and the one other end you will stretch with one hand. With the another hand you will do means what you will do is with the what you are stretching, no, that string you will tuck you will do, means you will what you can do, when you will do tuck you will do, and you will hear a feeble sound. This I will explain in the next class in my video, okay, where I will explain it. Today you can manage with the explanations. So let's start. So what is sound? Now let's explain about what is sound. Sound is a form of energy which produces the sensation of hearing in our ears. So sound is responsible for producing sound in our ears at any frequency or any scale. Okay, we'll go about frequency and scale. Let's talk about speed of sound in different mediums. Speed of sound in iron is 5000 meter per second minus 1. And speed of sound in air is 1500 meter per second minus 1. Speed of sound in water is 330 meter per second minus 1. So here what is wave? I have explained wave also. One complete compression and one complete rarefaction forms one wave. Here in this part, when one complete compression means the lines come very close as they normally are, and rarefaction are the lines go very farther as they normally are. So when two of the things occur at the same time, that time it is called as wave. Now let's go to the next slide. Hope you can understand. Now we'll go elastic wave. Elastic wave I will come. Before that we'll go discuss two types of waves, that is transverse and longitudinal waves. Transverse. The particles of medium vibrate perpendicularly to the direction of propagation of wave. So what is happening in transverse wave? The medium of the particles means is stayed by the line which are going up and down, going close and going very far. Those lines go perpendicularly to the direction of flow of sound. Means you know that when the boat goes beyond opposite the direction of the flow of sound, then it have to increase the speed of the boat, right? So here also that thing happens. The particles of the medium vibrate perpendicularly or oppositely to the direction of propagation of wave. Direction of propagation of wave is called transverse wave. Transverse wave doesn't depend on the sensitivity of the listener. Means it called that when different people and different sensitivities of particles, different sensitivity of the different sensitivity means one person can hear a voice with other sound of one person can hear a voice though it's a loud sound, but he hears it very faint. Now it cannot be measured by decibel scale. What is decibel scale? I'll come in my next class. I will explain. Now longitudinal wave. Here what happens? The particles of the medium go direct to the flow of sound. Means vibrate direct to the flow of sound. Means the boat goes that way when the sound is flowing. So it doesn't have to increase the speed. Means increase force or speed. So it depends on the sensitivity of the listener as it goes on the flow of sound, and it is measured by decibel scale. Sorry, here I have written cannot be measured by decibel scale, but it can be measured by decibel scale. Let's go to the next slide. Now we'll go about compression and rarefaction. These are the two forms which I have said. Now compression and rarefaction. Let's tell you the definition now. So compression is a part of longitudinal wave in which the particles of medium are closer to one another than they normally are. As I have said in the first slide that this is the compression. Air is a high pressure. Here high pressure, I have said that it have to increase its force to go to the opposite side as the flow is on other side, right? So region of high pressure is denoted by letter C. Rarefaction is a part of longitudinal wave in which the particles of medium farther apart than they normally are, and it's a region of low pressure. It is denoted by P. Okay, and compression and rarefaction forms one complete wave. Let's go to the next part. Now there are types of sound waves. Now we'll know about types of sound waves. In class 8 we are having longitudinal wave and transverse wave in the textbook which you are using, but I will tell you three types of waves, three types of extra waves, which are electromagnetic waves, mechanical waves and elastic waves. Explanation of the waves. Elastic waves. The wave produced due to periodic vibration of particles of elastic medium. Periodic vibration is explained that one compression and one rarefaction, and one compression and one rarefaction depends on the elasticity of the medium. This you have to remember. The wave is produced due to periodic vibration of particles of elastic medium. So wave cannot propagate without elastic medium. One compression and one reaction cannot propagate without the elasticity of the medium. So here it is called as mechanical waves or elastic waves. Okay. Elastic and mechanical do are same thing. Okay. So next is electromagnetic waves. The wave produced due to periodic disturbance of electric field and magnetic field. Electromagnetic wave are those waves which you will learn in class 10, but let me give a brief summary. That the wave which is produced due to periodic disturbance of electric field. Electric field is here explained as charge of an current. Charge of current, and magnetic field means you know that the positive charges attract each other and negative charge repel. So that thing is told here. So when the compression and reaction does go periodic means to the flow of sound of the current and the magnetic field, then it is called as electromagnetic waves. Mechanical waves, mechanical elastic waves are same thing. Let's go to the next push. So here terms related to sound wave. So first is amplitude. Amplitude is the displacement of particles in its mean position. Means in sound wave here displacement of particles taken. So it is called as amplitude. SI is meter denoted by letter A. Now what is frequency? The number of periodic motion performed in 1 second. Means periodic motion means the sound is going to the flow of the sound, to the flow of the sound. The wave is going to the flow of the sound. So the frequency counts the number how many times it goes. So in 1 second is called frequency. Now unit of frequency is hertz. Okay. Frequency is hertz. Okay. Frequency hertz. Acha, now what is time period? Now to occur a periodic motion of the sound particles, there should be a required time. So the time required to complete its one periodic motion is called time period. It's 70 seconds. Now we'll know about wavelength. The distance of particles of wave with one time period through the displacement of particles of medium. Here what is said that the one time period what distance is taken through the displacement of particles of medium. Means displacement of particles of medium it takes from in one time period. Means the distance it covering in time period in displacement of particles of medium is called wavelength. Its sound is lambda, or a lambda symbol I don't have, but in the next class I will show. Wave velocity. Now what is that? The distance traveled by a wave in 1 second. Means how much distance does it covers in one wave is called wave velocity. Its SI unit is meter per second. So these are the terms related to sound wave. Let's go to the next slide. Now we will know about sound intensity. It is not present in your book, but then also I am telling you. The amount of sound energy passing perpendicular to unit per area to unit area per unit time is called sound intensity. Means the quantity of sound energy passing perpendicularly through the area in per unit time. So the area of the sound which is covering in per unit time is called sound intensity. Now intensity depends on the following two factors: frequency and amplitude. So here two formulas, that two laws, that I proportional A square, here A is amplitude, and I proportional N square, N equals to frequency. Next I'll go about displacement time graph. This I cannot show the picture. If the picture is there, I'll show in the next class, next class. Displacement time graph. Displacement time graph shows us the displacement of particles or medium at a given position with time when the wave propagates through the medium. It's called displacement time graph. Here amplitude is represented by the letter A and time is represented by the T. So what is told? When a wave propagates through a given position with time, means with time the given position propagates through the flow of sound, is when the and it propagates through the medium, then it is called displacement time graph. Now we'll know about displacement distance graph. Displacement distance graph shows the variation of displacement of particles or medium with distance and time is same but with different is called displacement time distance graph. Okay, now let me tell you what is this. Here, what is the variation of displacement of particles of medium? Here the graph represents that time and distance is fully same but displacement is different. In this graph, displacement is same and time also same. Here only displacement is different, baki are same. Here time period represented by the letter T and wavelength represented by lambda. Now this is the last slide, characteristics of sound. This explanation I will not give today. Okay. This explanation I will not give today because this explanation is not available in my home. So next class I will prepare the PPT and send and tell you what are the characteristics of sound, what are the dependence and what are the factors in which they depend. So loudness, pitch and quality of timbre. These are the three characteristics of sound. So loudness depends on amplitude, pitch depends on frequency and quality of timbre depends waveform. What is waveform? Waveform means the wave which forming the going up and down, up and down. So thank you everyone. Hope you will understand me and go through all the slides which I have explained. Okay. Okay. So ending my class today. Okay. Thank you everyone.